Hey guys. um, Again, sorry for not really communicating with you guys. A lot of stuff's been going on in my life because of this whole virus thing, and it's something I want to get into. So let me just get that out of the way and try to help you guys understand action potential. Jeez, my clouds are so dirty. So action potential, resting memory potential, all that should be familiar to us, right? So I'm gonna draw it over here. This should look very familiar. Alright? So, if we remember in the muscle chapter, we had to deal with this so that we knew action potential, how our muscles worked, and all that stuff. Right. Now, if there's one thing I could say, excuse me, your textbook does not do a good job explaining this. A lot of the notes that she's provided, the slides and all that, do not make a good job at explaining this. Frankly, I find them very boring. It's kind of hard to, sort of keep up or follow along. So really all we have to know is a couple things. So straight line at the bottom, and I'll use a red marker to sort of put key information, right? This right here, this red line, or not this red line, this whole black line, this area right here, right? This is your commonly known as resting state. It's when your muscles aren't moving, nothing's moving, right? You have no signals being sent. Well, up here, if we remember from the muscles, you have your action potential, right? Now, we should remember a couple things. There's a dotted line going here. What is that? Well, we remember this is commonly known as threshold. All key things, but how do they correlate to each other? So, unlike the muscle chapter, which dealt with the permeability, the memory potential of a muscle fiber, right? This was the voltage of the muscle. This is dealing with our good friend. So I can draw it. Something like this, I tried my best. Right? But our good friend, the neuron, right? This is dealing with the whole thing about this. So, if we were to move up, we remember from the muscle chapter, this is commonly referred to as depolarization. Cool stuff, right? Move past this chapter. Going down, what was commonly referred to as repolarization, right? It's a long word. And when it dips down, resting state is always going to be -70 no matter what. But when we go below that, what is that called? Well, hyperpolarization, right? So, these all kind of should be familiar to us, right? But what leads into what? So, just for the sake of consistency, if we remember correctly, you need something to reach action potential. You need depolarization. What is that caused by? Well, we have to remember it's caused by our good friend sodium, an influx of sodium. So sodium is going into something. Well, into what? In this case, into our neuron. And this happens, let's see. If you look at our diagrams about the neuron, you know that the whole body of it is covered in these little sheets that protect it. You have these areas, the dendrites, which are these guys. You have the body, the axon, all this stuff. In this area here, right before you started reaching the whole strand, this is where action potential is generated. So this is where this starts happening, right? You get the influx of sodium coming in, this causes depolarization, which leads to action potential where it shoots down and you reach into a synapse. So remember the synapse, if you remember this little diagram, right? It looks like a sorry piece, right? And then you have little things in here, you have signal. So this action potential would be that signal coming down. So imagine this being all through here. So this area would be this guy right here. Right? Then you have, after action potential, you have repolarization. And repolarization is, if you remember, good friend of sodium is potassium. And that is caused by an outflux of potassium. So I'm actually going to write that. That would be too small to catch on the camera. Let me know if it is. So depolarization is sodium influx, a lot going in. Repolarization, once after we have the signal sent out, you have potassium coming out. But how does that happen, right? Well, again, think back to our muscle chapter. We have certain gated channels, right? So that's my crude little protein bean, right? And they do certain things, right? This guy, he allows for something in. This guy allows for something out. Right? Which the shades will be a different color because they're very different. This is, of course, potassium. This is, of course, sodium. So, to go in this step by step, we're sitting at resting memory potential. But let's say me, right here, right? I'm sitting here. I'm at resting state. Now, if I want to pick my hand up to start drawing on the board to help you guys out, my brain sends signals, my brain generates action potential in its neurons. It starts sending signals to that. You get sodium coming into my neurons, and I have depolarization coming out to form action potential, which is me doing all this stuff, you know, whoa, drawing on the board, crazy. But stop that, for me to just go back to that, potassium has to come out, and that will bring this state. So, oops, so like that, and this is that, right? Of course, after repolarization, we dip down below the resting state, and that is hyperpolarization. And all hyperpolarization is so put this underneath this. It's just hard to reach other AP, which is action potential, right? It's just a point when it's hard to go back up because we're below it. You can do it again, but you know, it just takes more on your body. But why is this important, right? Why should I care? Well, because this relates to everything else in the chapters we're going over. It's kind of like whenever I said for the muscles that you need to understand this because it's the breaking point. It's after this, everything else in the rest of the lecture will make sense if you understand how things work. So, we're sending it out like that, right? But why? Because you need to be able to send a lot of different things throughout your body, signals to do different things. We're going to touch more on this when we get to the synapse, like what these are, how they affect you and all that. So don't worry, we'll talk about that then. One last thing I guess you should remember. She didn't talk about this. I don't know why, but it's something you guys should have went over in the very beginning. But there's another type of sort of channel that dictates what goes in, what goes out. And it looks a little something like this, right? Something like that. This is referred to as the sodium-potassium pump. I don't know how many questions she's going to ask you guys about this one because, like I said, she didn't cover this earlier. It kind of should have been. But basically, what this does, it opens up at the top, allows something to come in, closes, opens up at the bottom. So in this case, we'd have like two little guys here, right? This is not to scale, unfortunately. But it would be like that, right? Instead of having a clear channel just to let things in and out, you would have this. And what it does is it allows potassium to go in. So it does that, it opens, potassium comes in, closes, opens, releases potassium in. But what it does also is once it opens back up down here to let potassium in, it does something else. Alexa, next. Sorry. Allows for sodium to go out. So we have that. So sodium goes ahead and gets out. That's simply how the pump works. I don't think she's going to ask you guys anything about that, but something you should know. Again, I don't think the doctors are going to talk to you about this kind of stuff, but it's just something that's a little bit more common. That's how membrane potential works. Again, it's not that I don't want to go that in depth into this, but there's a lot more I can do because I've already talked about this when we went over muscles. Basically, you just have certain steps going down, and whenever we talk about the synapse again in the next video, you'll understand how they're sort of related. But that's pretty much it for membrane potential. You really just have to know depolarization. So let me write some key things up here. Right. You just have to know depolarization, repolarization, hyper. What they do, what they are, how they work, right? When it comes to this. Because once you understand what is related to like sodium with depolarization, potassium repolarization, hyperpolarization, how it affects your body, then everything else makes sense. So again, I can't really go that in depth into this. It's kind of hard, but I put a bunch of videos, and if there's anything else I find, or I can make something if you guys really want me to, I don't mind at all. I mean, I have nothing else to do because quarantine and crappy internet. Like the most I can do is stream music. So that should be it. Yeah.